Continuing on with class 23, here is a problem out of Borgnacki, problem 678. A cylinder fitted with a movable piston contains water at 3 megapascals, 50% quality, at which point the volume is 20 liters. The water now expands to 1.2 megapascals as a result of receiving 600 kilojoules of heat from a large source at 300 degrees Celsius. It is claimed that the water does 124 kilojoules of work during this process. Is this possible? I don't know. Why would someone lie? I don't know. Let's see if we can make this a little brighter. And let's see if we can make it focus. There you go. All right, so I always draw like a little thing about it. I want to see what this looks like. Okay, so here's our stuff inside here. And it seems to me that we're putting heat in, and there's like 300 degrees Celsius is what's on the surface of this thing all around. So at state 1, we are told that the pressure is 3 megapascals. I like to use kilopascals. And that the quality is 50%. Therefore, it's a saturated thing that we want to look up. They tell us that the volume at 1 is 20 liters. We know that a liter is a 0.001, so this makes that 0.02 cubic meters. We look this up, and we look up the parameters that we need. So this, we'll just write them down. Table B.1.2, right? We need based on there. So we need the, do I need the specific volume? Yes, I think I do. So I'll find V1 right here by taking this quality and just looking up this quality and just looking up this parameter right here. So that ends up being 0.033948 cubic meters per kilogram. Same thing. I did it with, did I need it? Yeah, I think I do. I need U right there. And so UF and UFG, and then with the 50%, and I get 1,804.5. These are kilojoules per kilogram. And let's just assume we need the entropy because that's the topic du jour. And once again, you get the SF and the SFG and the quality, and you get 4.4162. So you should be able to do that, no problem. The other thing they told us, receives, it gets up to, so P2 is going to be 1,200 megapascals. So that'll be less, not megapascals, I mean kPa, sorry. I changed it from 1.2 to from megapascals to kilopascals. Anything else I want to know? Yeah, I guess they told us that Q from 1 to 2 was 600 kilojoules in, and that work from 1 to 2 was 124 kilojoules out. All right, so just as you'd expect. And okay, so we're good to go, I think. So what am I going to do? So I'm trying to say, I want to see if this claim is possible. So probably what I want to do is I want to see what the entropy generation is going to be, and to see if it's positive and therefore possible. So this is, we have to keep track of the signs as we go through this. I can find out what the mass is going to be because all of these are on a per mass basis, but they just gave these as not per mass, so we need to find out what the mass was. But we know the volume and we know the specific volume, so we go the mass is going to be that divided by that right there, right? So 0.02 divided by where'd you go? 0.033. Is that a 9? I think it's a 948, sure. And I end up with 0.5891 kilograms. I'll need that in a moment. So let's go for our conservation of energy, COE. U2 minus U1 is equal to Q12 minus work 12. All right, so what we're going to find here is we're going to be able to find what little u is going to be, right? So we start out with, I guess I'll write this out here, m times u2 minus 0.5891 times 1804.5 equals 600 minus 124. And this should have been, we know what the mass is. So that's why, I don't know. I decided to do it this way. 5891. I kind of squeezed it there, didn't I? I think so. So U2 is equal to, where'd you go, buddy? 2,612.5 kilojoules per kilogram. All right, so now we know what the internal energy is, and we know the pressure. So we have two pieces of information, so we could find the rest. So go to table B.1.3. We're going to assume this is superheated. It's a decent enough assumption, I think. So let's see. We can get rid of all these things. Probably wasting my time, wasting your time doing this. I don't know. I'm just going to close it and not say, don't save. So anyway, we're at, what do we say, 1200? So let's go up to 1200. Good enough, sure. And here's our internal energy. What did we say it was? 2,612. Oof, wow, right there. So go ahead and say that that's good enough. We don't even need to interpolate, right? 2,612.5, that's good enough. We all agree? Good enough, good enough. So we have an entropy right here. That's probably what we were looking for. So we'll say first off that the T2 is approximately 200 degrees Celsius, and that the S2 is going to be 6.5898 and kilojoules per kilogram degree Kelvin. And anything else from this? I don't think so. All right. And therefore, remember that our main equation, the guy that we care about the most, I don't know why I had to gender it, but I did, is this equation right here. And so we want to get that S gen, and it's going to be the S2 minus S1 minus that guy right there. So S2, S gen from 1 to 2 equal S2 minus S1 minus Q1 to 2 over T. And this T should be the temperature through which the thing will emerge. And so that's the 300 degrees Celsius right there. So we get mass times this minus that. So the mass is 0.5891 times S2, which is 6.5898, and minus S1, which was all the way back at the top, 4.4162, 4.4162, and then go minus the Q, which was kilojoules, right? 600 kilojoules, 600 kilojoules divided by the temperature. So that's going to be 300 plus 273. So the S gen from 1 to 2, make it look like what they're doing. Weird subscript thingy going on there. At a 0.2335 kilojoules per kilogram. It's positive. Therefore, we're going to say it's possible. Right? That was what we were looking for in the problem. Go back and read the original problem and see what they were asking. It says, it is claimed. Is this possible? Right? Is this possible? The answer is yes. So I might box in that whole thing to declare it is a possibility. It could happen. It could happen. All right, so the next example is a wicked long one. Let's see if we can get through it and then go to bed. It's 11 o'clock at night on a Sunday night, and I want to see what happened with the football games. The Bills aren't playing, so I don't care, really. And we're out of it anyway, I think, but maybe a miracle could happen. We'll see. We'll see. Goodbye.